Boy oh boy, I've been having a field day testing command block lag. So I've gone ahead and loaded up, I think it's a 100 by 100. Yeah, 100. So more command blocks than you'd probably ever use, but it is perfect for us to actually figure out how tick lag, so everything that's happening on this right hand side, really works. So we have a bunch of repeating command blocks here. There is absolutely no command in them, but they are always active. So the block update that these command blocks are triggering is causing that baseline level of tick lag that we see over here with the little green spikes. We get rid of it, no lag, you can see it's emptied. If we change this back to not active, so if I swap auto here to 0, summon them, needs redstone, so they're not active. We can see there was a spike in tick lag when they were placed, obviously, lots of block updates, but then nothing. Similar if we were to change them to normal command blocks, no issues. Repeating command blocks, exactly the same, no issues. For obvious reasons, none of these are actually operating, nor do they need any sort of block update to check. I meant chain, didn't I? Yeah, so chain command blocks. Because chain command blocks run off of other command blocks. Okay, so that's step one down. What this means is if you use repeating command blocks in any fashion and they're always active, there is a base level of lag that they are causing. Tick lag, more importantly. So remember, we have our frame rate lag here. So this is visual lag, so to speak, and then tick lag is actually the timing system that everything in the game runs off of. So if this is going bad, it's a lot bigger problems than if this is going bad, because you can just change your video settings, lower them. This is internal, so it's much worse. Cool. So what this means, again, is you don't want to use repeating command blocks. You want to, wherever possible, create systems of chain and normal command blocks to operate within a timer mechanism or a tick mechanism, similar to how data packs are set up. So data packs usually tie in a tick setting to whatever functions you're running. And what this means is you can control when they run. Granted, it is still limited. It doesn't have the constant lag caused by having a bunch of repeating command blocks, but there are a lot of other issues and limitations, if you will, to using data packs, which is why I avoid them. One, you can't create somewhat dynamic systems, because functionally they have to work in a linear fashion, or you have to set them up with, well, command blocks to run as functions if you want them internalized. So, what can we do? What else do we need to figure out? Well, if we go ahead and we stick a bunch of chain command blocks on top of these are non-active, no lag, good. But if we were to now make these always active with, again, no command in them, we change this back to a 1, delete them, place them back, you can now see there is slightly higher lag than when just repeating command blocks were in place. To showcase, we get rid of that, you can see the green bar over here drops down. So what this means is that now that the chain command blocks are constantly updating, they too are imposing block updates and therefore generating tick lag. Ooh, bit of a mouthful. But it does get worse. So again, to reiterate, you want to, wherever possible, set up timer systems and utilize normal command blocks over both chain and repeating, simply because of their checks. So whenever they're running, despite having no command, they're forcing block updates so that they can test whenever they are able to run a command. So if you were to put in a command, they need to be able to constantly test for that command. So how does it get worse though? Well, we'll get rid of both of these and we will start putting it in commands. For instance, if we do run weather, run, because there's no execute. If we just do weather clear, right, so now it has a pretty simple command in it. But there is a bunch more tick lag. So that green bar has almost doubled with a simple command as weather clear. If we were to make this something more complex, for instance, if we were to type out the attribute command, so attributes to us, just to make it specific, generic armor, modifier, add any random UUID, I think it's 5, perfect, 1, add, they'll do. Anything that modifies NBT data or updates an entity in any way causes a lot more lag, as we will now see. So if I go ahead and change this from weather clear to the attribute command, clear it, put it back, and that is dangerous. So right there, that colossal red patch is really, really bad. Because once this little, you can't even see, there we go. Once this drops below 20 ticks, that's when you have really noticeable problems. Depending on your computer, that would far exceed this point. You do not want to be above around 20 milliseconds, I think, on average, unless you have a really, really beefy computer or are running it through a server. Okay, so then what's the next thing to test? Well, is there a way we can reduce this? So for instance, if I were to put executes if entity, do I need the entity statement? I think I need the entity statement. It's a problem with working command blocks. I can never remember what we need. Okay, so we'll do type equals Minecraft husk. So this means unless there's a husk in the world, this command should not run. The test should fail. So if we go ahead, put it back. So in a sense, it's still trying to update an entity even though the command has failed. If we were to get rid of this starting portion of the command and just run the test, what about that? How much lag does that cause? Ooh, you know what? I deleted from the wrong part. I meant to keep the bracket. There we go. So all the way to husk, just like the little one we set up there. We'll get rid of it. We will replace all of these if I can find my hotbar. And, well, it's still a lot more lag than the weather clear command. Why is that? Why does this generate more lag than constantly running weather clear, a command that is functional and is updating the game? Well, simply put it, any sort of entity test means that this command block is now testing or sort of deciphering the data of every loaded entity in the world. So usually 16 chunks, all entities are operational, 32 chunks away, entities are still loaded but are not operational. So in a normal world, that means there would be a lot of entities that this command block is just testing. And this testing phase is really, really bad. And it doesn't matter how you sort of do it. So for instance, if we were to change this to, I'm going to try and type it out here. So execute at all, so that's us as a player, if entity, and then stick in, say, a distance parameter, .8. So this should theoretically limit the entities checked to 8 blocks around us. But unfortunately, that's not quite what happens. You can see it gets even worse. So what it does now is it's testing both us, the entities around us, and all the entities that are loaded. So despite making it a more specific statement, it is now far more complex and causing a lot more sort of calculations internally. This is where my math has run into significant problems, because I was using these tricks in theory to limit the amount of entities that are tested, but it doesn't run off of us. It runs off of every loaded entity and then filters. Even if we were to sort of make it a little bit more complex, so for instance, if we were to execute at us first, and then say do another run command, so we split up the statements that are questioning. So it has to find us, and then it has to find the other entities, right? So execute, we'll do execute at again. Execute at entities, again within 8 blocks. Slightly better, but still worse. So we split up the statement, so it is double checking. So it has to pass 2 statements first rather than correlating everything. So it does make a slight difference to phrase it as execute, run, execute rather than execute at, and then an if statement. So this is really important because in a logical sense, because again, remember this is really, really upscaled. Not even my map has this amount of command blocks. But what it means is it is really important that your statements are split up into set filters. You can't stick everything into one line. You can't do execute at, if blah, 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 if blah, blah, blah. You're far better off executing at and then running, execute, running, execute, running, execute. Because every time you add that layer, it's doing this part of the command first, and then this part of the command, and then that part of the command. And that segmentation is what is enabling it to sort of undergo less stress and less server load that is causing, again, tick lag. So what have we learned? Well, we've learned that repeating command blocks due to block updates are the worst. We've learned that depending on the type of command you use and what it does and who it affects, can make it significantly worse. So attribute commands, data modify commands, summoning commands, setting blocks or fill, they are all horrible in a sense because they are forcing updates within the game. They're either forcing updates on entities or updates on the world. Something like the weather clear is causing an update on the game state. So to put it in a simple way, 16 by 16 blocks makes up the world in one chunk. Yeah, so that's what's being modified with those commands I mentioned before. The weather clear command only has one world to modify. So that's really important to understand if we're going to sort of mow down this tick lag in, complex mechanisms. So then what does this mean for data packs? Because a big argument for data packs is the fact that you can compress statements and essentially run them all in one tick. Now, running everything in one tick is still an issue, because if you compress everything down to one tick, instead of having this nice spread between commands, everything that's forced on one tick will cause huge spikes. So you still need to sort of segment your systems in data packs or come up with far less complex systems, which is a big thing. Why data packs can never sort of eclipse modding, because modding is essentially editing the game state as a whole, that all these updates are forced in a more calculated way rather than running different checks. Because even a data pack still has to run checks. It's still causing the game to sort of calculate things and run differently to Minecraft in its normal sense.